Let's look at the membrane for a moment. Yeah, the gas exchange is happening through a membrane. The activity of the membrane is interesting in itself, but it's also the place where the important processes are happening. And that's why it's worth looking at it a little bit closer. There's a problem in osteopathy with looking at membranes because culturally we were not focused on that. Yeah? So this might be obvious. Yeah? I think it has a few obvious reasons, but definitely there's a cultural problem in osteopathy because we were not trained to look at the activity of the membranes. And one of the reasons is because it is local, and it's not it's auto-regulated and it's biomechanical. But the most important reason probably is that it's not due to motion and flow. So flow and motion are not the driving forces of local gas exchange. Any kind of local exchange in the alveoli or in the capillary system is not because of motion and flow. Of course, there's motion and flow, but these are not the dominant forces that define gas exchange, and that's important to understand in physiology. And it's local gradients, it's in the periphery, and it's auto-regulated, and often the auto-regulation is biomechanical. And for some strange reason, this is not so did not interest osteopathy so much. So that's the cultural problem. So what is it about? Yeah, it's about the peripheral activity of the capillary system. Yeah, capillaries is like where there are no muscles. There's only endothelial tissue. So the nervous system has nothing to do there. There's nothing the vagus can do there, or the sympathetic system. They're local metabolites that regulate it, but it's very important because in the end, when we die because of tissue degeneration and tissue death, and it's because of local ischemia. So it would be really wonderful if we could do something locally there. No? Everyone wants to do that. Everyone wants to work on the local circulation. So if you claim to work on the circulation in osteopathy, if you claim to do vascular techniques that have to do with vascularization of organs and tissue, this is what you would have to be able to reach. So it's the capillaries that define if there's gas exchange or not, or exchange of any other things. So the capillaries have pores. Yeah, this is where the transport happens. It depends a little bit on the kind of organ we talk about. So there's different kind of pores. Yeah, so here you see one big capillary and a blood cell in it. So that's an ideal. And then you have different pores in the blood-brain barrier. It's a very strong barrier. Yeah, so the blood is definitely not allowed to go into the brain. It's a disaster. Yeah, if blood and nerves are mixing, that's bad. So if the nerves are in the blood system or the blood is in the brain system, in the nerve system, it's a disaster. So the pores are different in the sponges. It is the liver and the spleen. We'll look at that in more detail later. And of course, in the kidney, the glomeruli also have very different kind of fenestration. So that's the sinusoid system of the liver, and the spleen looks similar, even a little more loose. So this is kind of the fenestration there. This is kind of what we try to end up working. Now in class, we'll do some techniques that work on the flow of the blood in the liver, but then we also do techniques that work on the tissue itself. And that's where we try to end up working in the sinuses where the hepatocytes are. So this is kind of the liver tissue where we want to end up. So the glomerulus of the kidney, it's built for filtration. So very interesting build of the filtration and the fenestration system in the capillary system. And then the blood-brain barrier, very important, and it only allows hydrophobic molecules and small and polar ones, non-polar ones like O2, CO2, and hormones. So it's a very protected area, our brain, and it's important that things don't get there that have nothing to do with our brain activity. And of course, we have glucose. We need a lot of glucose in our brain. and there's actually an active transport, so it's not gradients. Yeah? So concentration gradients are passive, so that's very good because they don't use energy. So the brain has an active system to pick up glucose. Okay, so there's often a problem in our when we teach and also when we study something, that we have good ideas, basically in didactics. Yeah? So it's basically the art of teaching. Yeah? So you find a way to teach something that's more complicated, to make it simple, but then you start using images or basically simplified versions that are actually not representative of reality anymore. So when you do the vascular physiology, we often start with the heart, and then we go to the arterial system and the capillaries and the venous system. This is okay, yeah, that's part of it. But if that's your only image, you're wrong. It's a lot of things don't happen this way in the vascular system, yeah? And you don't actually understand the important parts. Yeah? For example, the capillary is it's kind of where everything happens. Yeah? So that's why we will start later when we do the treatment. Also, when I talk about the realistic physiology, then we'll start with the capillary system. Okay, so we have the same idea in basically the rule of the artery. No, it's kind of, I call it the role of the artery. It's something that is supposedly still said, and it's very confusing because I'm not sure what he actually. Oh, sorry, there's a spelling mistake. It should be artery. So to assume that the artery is so important in regulation, that is just not okay. That's wrong. I mean, whatever still thought about it, it doesn't match what we know about physiology now. So you can regulate the artery, but the circulation is much more dependent on the capillary system. So it's an illusion to work all through everything like using the rule of the artery. If what we mean by that is like saying that you have to work on the arterial system and the sympathetic system. You don't have very strong effects on circulation by doing this. So be careful that the didactic ideas, yeah, the way you want to teach a system, you start believing it, yeah, and that's one of the examples in osteopathy. We have the same for example, with the lungs. Yeah, so a lot of work is done on the bronchi. There's a lot of ventilation techniques, but ventilation has nothing to do with membrane activity. So there's a lot of wrong assumptions about the way the lung functions because the way it's taught. Yeah? So if you start with the bronchia alveoli and you end up with the membrane, that's correct. But the main activity of the lung, the function of the lung, has to do with the membrane and nothing else. So when you work where it matters on the lung, you have to work on the barrier between basically air, gas, and blood. So it's a gas blood barrier or blood gas barrier. So you have to work on the alveol, on the membrane of the alveoli. So this is kind of where you want to end up working. So you can ask yourself, yeah, the same like with the rule of the artery, how many techniques did you learn that are working on the gas exchange? I personally, I studied 35 years ago. I learned probably 100 ventilation techniques and there was no gas exchange technique. And I think it's probably still very much true. My experience in the pandemic was very clear. Most osteopaths have no idea how the alveoli take up air because they were very fascinated by forced ventilation techniques and they didn't understand what is actually happening in the alveoli. So gas exchange techniques is like what we do in class. Yeah, those are ventilation techniques we have, so no problem. We can also do them. They're good for ventilation, but you cannot ventilate a lung if ventilation should mean like gas exchange. Yeah? So this is illusionary osteopathy. If you think you're going to ventilate and then you change the gas exchange. Yeah? Gas exchange in the lung, it depends on very different things than ventilation. So, yeah, so we want is realistic osteopathy, realistic, at least in the sense that it's clinically realistic and also based in physiology. And that's why sometimes we start in the periphery, yeah? with start at the alveoli level where the membrane is, at least if that's what we want. If you're always able to do it, that's a different question. Yeah? But the lung function starts at the membrane of the alveoli. And then also we are able to actually understand the difference between blowing air into the lung and basically blowing the lights out. Yeah, so it's very difficult to ventilate a lung using